Okay, so here we are, 2.4c, solutions of linear inequalities. We're in double inequalities here, and this is the same picture I had on 2.4b. All right, so we've got this kid who takes 4 tests, and he earns grades right there. Okay, if all 5 tests count the same, what grade must the student earn on the final test so that his course average is a B? That is, so his average is at least an 80% and less than 90. We're not interested in what a C looks like or what an A looks like, just an 80 or just a B. So notice what we've got here. In order to find his average of 5 grades, we have to have 5 grades here divided by 5. Regular old, how do you find an average? Now that average has to be between 80 and 90. So see, we have an inequality here and an inequality here. So that makes it a double inequality. Okay, we have 3 parts. All right, so we're going to add all these up. So we get 356 when we add these 4 numbers up plus x, because we can't combine that, over 5. Everything else stays the same. Multiply the entire thing by 5 in order to get rid of this fraction. So 80 times 5 is 400, and this times 5 just cancels this 5 with the 5 we multiplied by, so that stays the same, and 90 times 5 is 450. Then we subtract 356 from this side and from this side. Now when you're dealing with double inequalities, what you normally are doing is you're getting rid of stuff in the middle here. So whatever you get rid of, you have to subtract from this side and this side, or add or divide, or whatever you have to do. In this one we have this added to x, so in order to get rid of it we have to subtract it from both sides. Well, this, in a double inequality, you have this side and this side. So 400 minus 356 is this, 450 minus 356 is this. So now you have an inequality with 3 parts, but only a number there and a number there. So what does that tell you? That tells you that this student must get a grade on his final test somewhere between 44 and 94. He could get a 44 because it's got to be greater than or equal to 44, and it has to be less than 94. If he gets a grade higher than 94, then his average for the course is going to be different than what they're asking for. So to get a grade of a B, he has to get this grade somewhere between there. Okay, so let's look at graphing this real quick. Here is our original problem. Our grade here, our average right here, has to be between 80% and 90. So what we do is we graph 80 on our graph, which is right here. We graph 90 on our graph, which is right here, which basically means we say y equals 80 and y equals 90, and also y equals this middle one. Okay, so y equals 80 gives us a horizontal line, which I showed was right there. Y equals 90 gives us another horizontal line, and if we graph this, you can either plug it in your calculator or figure it out algebraically, and you get this graph right here. And what we're interested in is when your score is between an 80 and a 90. So somewhere along this line is going to be your answer. Okay, starting with this and going up to this. Okay, so last one here has to do with example 7. The mean or expected time y served in prison for a serious crime can be approximated by a function of the mean sentence length x with y equals 0.55x, and again, you do not have to know where this equation came from, where x and y are measured in months. So according to this model, to how many months should a judge sentence a convicted criminal so that the criminal will serve between 37 and 78 months? Okay, so that's what we're looking at. We're looking at a time in jail between 37 and 78 months. Okay, so it says between 37 and 78. So that between means we have a less than or equal to here and a less than or equal to here. And the equation, 0.55x minus 2.886, will go between there. Okay? All right, so then again, we are just trying to get the x in here. We're trying to get that all by itself, so we're going to add 2.886 to this side and to this side, giving us 39.886 here. Nothing was done to the 0.55x, and we're going to add it to the 78. Okay, then we're going to divide both sides by 0.55, and again, we did not divide by a negative, so signs do not change. Okay, so that goes away, and we're left with 72.52 and 147.07. All right, so what does that tell us? That if the judge wants the criminal to be in prison somewhere between 37 and 78 months, okay, with parole and good behavior and all that other garbage, okay, then in order for them to have to be in prison that much, the judge needs to sentence this bad guy for between 72.52 months and 147.07 months. If they sentence him for somewhere in between here, they will end up being in prison for somewhere in between here. Okay? So, basically 73 months to 147 months, that will work if they want them to be in prison that long. Okay? So I like the double inequalities a whole heck of a lot better than I do the initial ones. But in your homework, what you're doing is you're in exercises 1 to 12, you're solving inequalities both algebraically and graphically, and then draw a number line graph of each solution and give interval notation. So remember, the interval notation is when you have something like negative infinity to 32, and you have it either boxed or rounded. That's interval notation, just as a reminder. 13 and 14, I had mentioned solve graphically by the intersection method and told you didn't really need to spend a whole lot of time on that because there's only 2 problems. And then also 15 and 16, solve graphically by the x-intercept method. That was back there a couple pages back. And then we get over to 19, solve the double inequalities. You're just solving them like I did this one right here. Okay, that's all you're doing. And then you get into some story problems there. So that is it for 2.4 and Chapter 2.